This short video is going to show you how to do the TinkerCAD assignment, number 1.7, to be turned in this week. So let me share my screen and walk through how to find that and how to do it. This is our course page. You probably already know that if you go to modules, I'm not going to have time to do the traffic light build in the lecture, so this supplemental video will cover that. If you click on this, you'll get the instructions for that traffic light build. Let's go up here where we find the instructions. There are two ways you can look at the instructions. One of them is click here where it says the instructions, and that will let you look at them within Canvas. I don't recommend that. It's kind of clunky and it takes a long time to load. What I would recommend you do instead is right next to it, there's a little download icon. I would click on that. And so it's going to download the traffic light instructions right here. And they're going to look like this when you open them up in Word. This is what your completed traffic light circuit will look like. This is an Arduino microcontroller board. It's a little computer. This chip right here, this integrated circuit, can be programmed to read inputs and write outputs. So the connectors here at the bottom and the connectors here at the top are all connected to the microcontroller, and it looks for inputs and it sends outputs on these different pins. Now, your project is not going to have any inputs, only outputs. So it's going to be a little bit simpler. The Arduino board is really popular with hobbyists, electronics majors who are doing school projects and things, because it's easy to learn and easy to use. It's not really a professional platform. So once you become an engineer, you'll be using more sophisticated microcontroller platforms, but they'll be more difficult to learn because they can do more things. Anyway, here's the microcontroller part of the board. These are all clock circuits and to make it oscillate and to regulate the voltage and other things to make it work. Here's a USB connector. This is what powers the board and allows you to download code into it. Now, this is just a graphic, right? This is a simulator. So there really is no physical connector here. This just shows you what it would look like, so you can visualize what this circuit would look like. The way it works is here are traffic lights, red, yellow, green, red, yellow, green. And of course, they represent the north-south traffic lights and the east-west traffic lights. So when it first turns on, the east-west light will be red and the north-south light will be red, and all the cars will be stopped momentarily. And then either the north-south or east-west light will turn green. When it turns green, then the north-south cars will go back and forth for a while, and then the yellow warning light will come on, and then the red light will come on to stop the north-south traffic. And then the green east-west light will come on, and cars will go east and west for a while until the yellow warning light comes on, and then the red light comes on, and they all stop. So that's the gist of how this traffic light is going to work, just like you're used to in a real traffic light on a real intersection. Now, the way the wiring works, this red wire is a 5-volt wire. There's a 5-volt output right here on the Arduino board. That's a 5-volt output. And it comes up here, and I'll show you in a little better picture how that's connected. It connects to a resistor, and the resistor connects to these 3 lights. So when you want to turn, let's say, the red light on, so this red wire here comes to an Arduino control pin, that Arduino control pin will be grounded. Current will flow out of the 5-volt wire through the resistor, through the LED, turning it on, and back down to ground on the Arduino board. And then when you're ready to turn that light off, it'll put 5 volts on this pin. So you got 5 volts on one end and 5 volts on the other, so no current will flow anymore. So that's how you turn the lights on and off. Let's go to TinkerCAD and see how to build this circuit. TinkerCAD is not a program that you download and install on your computer. It's an online application. And when you go to tinkercad.com, you're going to have a screen that looks kind of like this one. You're going to have a choice to log in or sign up. Since none of you have signed up yet, probably, that's what you're going to want to do. Click on sign up. Do not join as a class. Create a personal account. Personal accounts are free, and it doesn't tie you to a class, so you can continue to use this after this term is over with if you want to do some Arduino work. So I'll click on create a personal account, and you've seen windows like this before. You can sign up with email or Google or whatever. So go through the steps it takes to do that. And once you do, you're going to log in. And when you log in, you're going to get a screen that looks like this. So here's me logged in. There's my username. It arbitrarily assigns these letters and numbers to it. But I want to, you should click on the designs link. And yours is going to be empty. But under circuits, I've got 3 circuits I've already done in the past. Here's some with keyboards and LED, LED displays or LCD displays. And here is our project for this class. I've already done it, gone through it, works great. But you're not going to have this yet. What you're going to have to do is create a new design. So go over to new, click new. You're going to design a new circuit. Here's the workspace. This is where you're going to build your circuit. Here's all the components you can use. Now, if we go to the instructions, here's where it tells you how to bring those components over here into the workspace and how to add the LEDs and resistors. And I'm going to show you how to do that. So when you go back and read these instructions, you'll be able to say, oh yeah, I saw how to do that. That's pretty easy. So coming over here, back to our workspace, the first thing we're going to need to have is the Arduino board. So I'm going to grab the Arduino board. I'm going to left click on it, drag it over, put it in the workspace. And then I need a breadboard. So I'm going to click on the breadboard and bring that over as well. I'm going to try to match the configuration of the instructions as closely as I can so it'll look familiar when you actually do them. I'm not going to give names to these components. They don't need names. Okay, got that part. Now, if we go back to instructions for a second, you see we need to add some components. We need to add some LEDs and some resistors. This is the north-south circuit. This is the east-west circuit. I'm not going to do the east-west circuit with you, just the north-south circuit. And then you can do the east-west in a similar way on your own. So we're going to need some LEDs. If I go up here, there's the LEDs. So grab one of them, left click, drag it over. I'm going to put this one right here. Now it's important to understand how the holes work. These holes right above the red line, see if I touch one of them, all those other holes turn green. That means they're all connected. There is actually a plastic proto board that looks just like this, that's got metal clips underneath that you can plug real components, real wires into. The Arduino board in real life looks just like this one. So this is a very realistic graphical representation of what this circuit would look like if you built it. And see, I've got the LED plugged into 2 different holes. Well, up here, the horizontal wires are connected. Now see the row above it next to the black line, those are all also connected. Now they're not connected, the 2 rows are not connected, but all of the holes in each row are connected. So if I plug a wire right here and I plug another one right here, they're connected together. Down here in the middle of the board, they're organized in columns. So here's column number 10. And you can see when I touch one of the holes in column number 10, all those other green holes light up in green, meaning they're all connected together. So are all the column in number 11, but column 11 is not connected to column 10. And column 9 holes are all connected, but not connected to column 10. Also notice that down here in the bottom part of the board, these holes are all connected in each column, but that column is not connected to the one above it. So we've got 1, 2, 3, 4, we got 5 holes in every column. That means we can connect 5 components together by plugging one of the leads into that column. The next component we need is a yellow LED. So I'm going to grab another LED. I'm going to put it right here. I'm going to try to hook up the same way the instructions show so that you won't have to figure out what's different. This one we don't want to be red. We want this to be yellow. So I'm going to click on this down arrow and select that LED to be yellow. Need one more LED. So here's the last one. And I'm going to plug that one in right there. And I'm going to make that one green. So there's our red, yellow, green LEDs. Now, if too much current flows to an LED, it'll burn out. If not enough current flows to the LED, it will not turn on. So we need to regulate the amount of current within a range that will operate properly without burning it out. And the way we do that is with a resistor. So I'm going to grab this resistor, and I'm going to connect that resistor right here. That resistor needs to be 100 ohms. The one I just put there is 1,000 ohms, which is way too big and the light won't come on properly. So if I put 100 in here and select ohms instead of kilo ohms, that's a 100 ohm resistor. I don't know if you noticed, but the color of the stripes changed. The color of the stripes on a resistor tells you what the resistor value is. Your resistor should have brown, black, brown. If it doesn't have other colors in there, you need to go back, click on it, change the resistance to the proper value. Now we need to start adding some wires. Remember that 5-volt wire that I said the current will flow out of the microcontroller board into the LED? Let's create that wire. So here's the 5-volt pin right here. I'm going to click on it. And if I hold the wire, see if it will just follow my arrow and go wherever I say. But you may not want a straight wire going all over the place. You may want to route it a certain way, which I'm going to do. So I'm going to pull it vertically down for a little bit. And then I'm going to left click again so I can change directions. I'll pull it over here a little bit, and then I'll left click again, and I can go up. And I'll left click again and plug it in right there. Oops, click on that hole. I'm going to make that wire red. The reason I'm making it red is because by tradition, 5-volt wires are red. Now, it doesn't really matter what color the insulation is. It just makes it easier for someone else to follow along what you're doing. Now we need a ground. Oh, this red wire now is connected to all these pins. See the resistors connected to one of those pins? So that red wire is connected to the top of that resistor. Now we need a ground wire. So I'm going to grab the ground wire, I'm going to do the same thing. I'm going to change directions. And you can route these some other way if you want to, but put the ground wire right there. And since ground wires are traditionally black, I'm going to change that to black. So now we have a route for current to flow out of the board and get to the resistor. We need a path from the resistor to each one of the LEDs, and then from each LED back to the circuit board. So what I'm going to do is put a wire between the resistor and that LED there. I'm going to put a wire from the resistor and that LED there, and a wire from the resistor to that LED there. So now current's going to flow through the resistor, along this wire, through the green LED, and I got to put a wire leading it back to the microcontroller, and that green wire has to go, according to the instructions, on pin -3. So I'm going to grab pin -3 and stretch a wire over to there. And I'm going to make that green because it goes to the green LED, but the color doesn't matter really. Okay, the yellow LED goes to pin -5, which is that one. And I'm going to make that wire yellow. And the red LED goes to pin number 7. And I'm going to make that one red. So there's the north-south circuit. You're going to have to create the east-west circuit yourself in a similar way. Let's go to the instructions. Okay, so we've added the components, we've wired them all up. So here's the ground and the 5-volt wire. It doesn't show all the other wires, but in words, it explains how to do what I just did. Okay, then you come down here and it's time to put the code into the microcontroller. So this is step number 4. On step number 4, we go over to your design and click on the code button. Here where it says blocks, there's a down arrow. It's a drop-down menu. Select text. And this is some skeleton text or skeleton code that's in there. If you were going to write your own program, you would start off with this and add to it. We're not going to use this code. We're going to use the code that was already been written for us. If you go to the instructions, down below under step 4, you'll see all the code you need to do. And it says to copy paste it. So we're going to start here at the top of the code. We're going to go all the way to the bottom. Control C to copy. Go back to our circuit. And we're going to replace this code with the lab code or the project code. There it is. Now here's how the code works. Starts off with variables. This is where it assigns these pins names, and the names will be the names of these lights. And then it comes down to setup. It runs through the setup code one time. And it establishes which pins are inputs, which pins are outputs, whether you're going to write a high or a low, what you're going to do. And then it gets to what's called the loop. And it goes to the loop over and over and over. It just runs that loop until you finally turn it off. So here's what's going to happen. You come down through here. The first instruction says digital write. It's going to write a digital logic level, which means 5 volts or 0, to the north-south red pin. And it's going to write a 0. That's what the low is. If it writes a high, that's 5 volts. Writes low, it's a 0. So over here at the north-south red pin, which we identified up here in the variables, we're going to write north-south red. We're going to put a 0 on it. So let me get that out of the way so you can see it. We're going to put a 0 right here. That means if this is 5 volts, current's going to flow out this wire, up this wire, into the board, along the clips underneath the board, to the resistor, down through the resistor, across to the LED, up through the LED, back down to ground on pin 7. That turns the LED on. When we want to turn that LED off, let's see, that would be here, north-south red. See, it says turns it off. We put 5 volts or high on that pin. If you have 5 volts on one end of the circuit and 5 volts on the other end of the circuit, current's not going to flow and that light's going to turn off. So that's what's going on with that circuit. Let me show you what it's going to look like when you run your simulation. I'm going to go back to the completed circuit. It's this one. Tinker this just means we're going to work with it now. So click on tinker this. Okay, here's our code. Here's all the components we had. Click on start the simulation. So what's going to happen is both these red lights are going to turn on. So the north-south and east-west traffic are both stopped. And then one of the green lights will go on for that direction to drive through. And then the yellow warning light will come on, and then the red light will come on for that to stop. And the green light for the other direction will come on, and then the yellow warning light, and then the red light. It's going to go through that loop over and over and over again. So starting the simulation, this initializing, it's going through the setup code. See, they're both red. There's going to be a delay there, and then the east-west light turns green, and then it turns yellow, and now it's going to turn red, and the north-south light's going to turn green. There we go. And then the yellow light's going to turn green or turn yellow. And then the red light's going to turn on. And it will do that over and over and over again. Okay, let's get the code. I told you how it worked, how here's the variables that establishes which pins are what names. And then here's where it's going to turn on each pin, turn off each pin. Notice that there's a delay between each time the lights change. So the delay that's been pre-programmed for us is 3 seconds. That's 3,000 milliseconds. Here there's a 3-second delay. Here's a 2-second delay. Well, those delays are pretty unrealistic. Part of the project is you're going to calculate what those delays should actually be. And in one of the assignments this week, there's going to be a document that's written about traffic, and it will give you equations that you're going to program into Excel, and then you're going to calculate what each one of these delays need to be using that document and using Excel. And you're going to plug those delays into these arbitrary placeholders of 2 and 3 seconds. So that's where you're going with this. I hope that helped. And if you have any questions, remember that office hours are on Thursday night, and I'll be happy to help you in person.